Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.4, day 2, entitled More Trigonometric Graphs. And today we're going to talk about the cosecant and secant graphs. So in the previous section of notes, we talked about tangent and cotangent graphs and how you make them. So today we'll talk about the secant and the cosecant, which are the inverse of the cosine and the sine functions. Okay, now this is just a reminder. This is the same little box that we had for the notes yesterday that shows the basic form for the tangent and the cotangent functions when you're graphing them. And it also shows the basic forms for the cosecant and the secant functions. And remember that since sine and cosine have a period of 2 pi, the cosecant and the secant are also going to have a period of 2 pi when you make those graphs. And remember that cosecant is the same as 1 over sine, and secant is the same as 1 over cosine. So these functions, since they have fractions, they are going to have instances where the denominator could be 0. So sine is 0 at 0, and then at pi. Okay, so cosecant is going to be undefined at 0 and pi. Okay, and then it would also be undefined at 2 pi as well. And then secant is 1 over cosine, so it's going to be undefined whenever cosine is 0, and cosine is 0 at pi over 2 and 3 pi over 2. Remember that we don't call 3 pi over 2 3 pi over 2. We like to refer to it as negative pi over 2 more so now, but it's the same thing. Okay, so that negative pi over 2 and pi over 2 and 3 pi over 2. That's where we're going to have our asymptotes for the secant graph. So if we're going to graph the cosecant function, we're going to take the reciprocals of the y coordinates of the points on the graph of the sine function. Okay, so let's do that. Let's graph the cosecant. Okay, and again, I'm going to make a table of values. I'm going to have x and y, and we'll start at 0, and we'll go all the way up to 2 pi. And I'm just going to pick nice values here. If I look at the previous page for sine, if I pick pi over 6 and pi over 2 and 5 pi over 6, even 7 pi over 6, 3 pi over 2, 11 pi over 6, if I pick those values, then I just have to deal with the 1/2s, and those are really easy to take the reciprocal of. So just in the essence of time and keeping things easy, we're going to pick those values. So we'll just do pi over 6 and pi over 2, and then 5 pi over 6, and then pi, and 7 pi over 6, and 3 pi over 2, and then 11 pi over 6. See if I can squeeze it in there, and 2 pi. You can kind of see that. We'll have 2 pi at the end there. Okay. All right, so at 0, sine is 0, so that means the inverse then is 1 over 0, so that's undefined. Okay, at pi over 6, sine is 1 over 2, so the inverse will be 2. And then the inverse of 1 is just 1. Inverse of a half again is 2. Inverse of 0 is going to be undefined. Okay, inverse of negative a half, that'll be negative 2. And then negative 1, and then negative 2, and then undefined again. Okay, so at 0 and pi and 2 pi, we have vertical asymptotes then. So at 0 and pi and 2 pi. That's where our graph is going to be undefined. So we have our vertical asymptotes, just like we saw with the tangent and the cotangent graphs. And then at pi over 6, I've got a value of 2. And then at pi over 2, I've got a value of 1. 5 pi over 6 is right about here. I have another value of 2. So this little part of the graph looks very much like a parabola. And then I have my undefined asymptote. And then I'm going to go to -2 for 7 pi over 6. And then -1. And then -2 again. So here I have another parabola. So it's kind of like I've got two little parabolas here. Now, this is how the cosecant function is going to look, the basic one. It's going to have these little u's or these little, I don't know what you call that, upside down u, or like an n sort of, lowercase n. So it's going to have those shapes. It's like horseshoe shapes, I guess we could call them. And basically, if you draw in your sine function, remember sine starts at 0. Whoops, didn't change colors. When did it change colors? There we go. Starts at 0, and it goes up to 1, it goes back to 0, down to -1, and then back up. So this is your sine curve. Okay? So the inverse of that curve then is going to be a curve that's flipped around. And here you've got a curve that kind of opens up, so the inverse of that is going to be a curve that's flipped around and opens down. So it kind of makes sense, and I think the book does a much better job of putting that picture together for you right here. Okay? So the red here in this picture, this is the cosecant graph, and then the blue, this is the sine curve. Okay? So you can see how this curve here, the inverse of that would be this parabola shape. And the inverse of this blue curve would be that red parabola shape there. So it kind of makes sense. Okay? And then again, you can repeat this. You can make as many periods as you want. Okay, so we're starting at 0 and then we're going to 2 pi. You can sometimes chop them in half if you want. Okay? Or you can make it go to the negatives as well. All right, now we're also going to make our secant graph. And remember, secant is going to be the inverse of the cosine. So we're going to take all our cosine values and we're going to do the inverse or the reciprocals of them. And again, we'll pick nice values. So let's do 0, and then we'll do pi over 3, pi over 2. The inverse of 0 is going to be undefined. And then we'll have 2 pi over 3. Okay? So we'll just pick these nice values in here. We won't pick those ones that have the radicals in them. We could, and they would give us decimals. But just for the interest of time, we'll just skip them for now. Okay? So I'm going to make my x and y table again here when I'm making my secant graph. And we'll start at 0, and then we'll do pi over 3, pi over 2, do pi over 3. Again, I'm just going around the unit circle, and I'm picking radian measures that are going to have nice cosine inverses. 3 pi over 2 would be the next one. 5 pi over 3 has a nice one, and then at 2 pi, we'll stop there. Okay? So, the inverse of 1 is 1. Okay, and then at 3 pi over 2, cosine of that is 1/2, so reciprocal of that is 2, or inverse of that is 2. Then we'll have undefined. Inverse of 0 is undefined. Then we'll have -2, -1, -2. Then we have another undefined here, and then +2 and +1. So again, you can see a pattern forming here, but we're going to have asymptotes at pi over 2, and then 3 pi over 2, okay, or negative pi over 2, 3 pi over 2, and negative pi over 2. They're the same, okay, same spot on the unit circle. Okay, and then at 0, we have a 1. And then at pi over 3, we've got, let's see, pi over 3 is over here. So that's going to be a value of 2. right about there, and then it's undefined. So we have kind of like a little half of a parabola here. Now the other part then, of course, would be over there, okay, but we started our table at 0, and then at 2 pi over 3, that's going to be at negative 2, pi is going to be at negative 1, okay, so negative 2, and then another negative 2, 4 pi over 3, okay, so I'm going to have another little parabola that opens down here, and then after my asymptote, I go back up to 2, and then to 1, and then I would keep going, okay, that little swoop would keep going, but I'm running out of graph there, okay. So if you didn't have this part here that goes from 0 to negative pi over 2, okay, the little half of a parabola and then the bottom parabola and then this other half, that's what a traditional secant curve looks like, okay. I like to include that whole parabola here to the left, or even the whole parabola over here to the right, but technically it starts at 1 because, or at 0, 0, 1, because that's where the cosine function starts. Okay, cosine starts at 1, then it goes to 0, then to negative 1, then back to 0, and back to 1. So this is where our cosine curve is. So if cosine starts at 1, then we have to have this little half of a parabola that technically starts our inverse function graph. And again, the book does a better job of graphing that. Okay, so you can see the blue here is the traditional cosine function. So then the inverse of this first little half of a curve is going to be this half of the parabola shape that opens up. And then you've got the inverse of this curve here from pi over 2 to 3 pi over 2. That's going to be that parabola shape that opens down. And then you've got this other little curve here that ends the period of the cosine. So then you've got your other little half of a parabola. Okay, so technically the secant is at like a half and then it opens down. Okay, but these graphs are still going to have, whoops, a period of 2 pi, okay, or 2 pi over k. All right, so this is what it looks like if you repeat several periods of the secant function. So that looks a little bit nicer, a little cleaner. You see all of the little horseshoe shapes, little parabola shapes. All right, now when we're dealing with transformations of our cosine and our secant curves, we're still going to have to deal with an amplitude, but we're not really going to, it's not really going to be an amplitude. What we've thought of in the past as an amplitude is now going to be a horizontal asymptote. Because notice on these graphs, let me go back to the picture for a moment, they have a horizontal asymptote here. Okay, those little parabolas never come below that part, and they never go above that part there. So there's this empty space here that the graph never gets to. So we're going to have horizontal asymptotes in our graphs. So our amplitude is now going to kind of be more of a horizontal asymptote. Okay, and we're still going to have a period. Okay, these graphs are going to have a period of 2 pi over k. And we're still going to have vertical asymptotes. So that's similar to what we were thinking of with our cotangent and tangent graphs as well. We want to set them equal to the values that are going to make the cosecant and the secant undefined. Okay, and up here, let me see if I can go back to my graphs real quick. Okay, the cosecant curve had an asymptote at 0 and at pi. So that's going to be the values that we set the k times x minus b equal to. And then the secant had asymptotes. We consider the first asymptote to be negative pi over 2 and then pi over 2. And then we'll do the other one as well, the 3 pi over 2. Okay, and I'll talk about that in a moment. We really need to make sure that for these, we have 3 asymptotes so that we can get these complete parabolas or these little horseshoe shapes in there. Okay? But notice that for both of these, they start by opening up and then down. So the first one opens up and then down. And then same thing here for, go to it. There we go. For the secant, the first little parabola opens up and then the next one opens down. So that's nice that they kind of both follow that same pattern. Okay, but again, there's going to be a lot of little details that we got to pay attention to as we're dealing with our cosecant and secant curves. So make sure you have this down. This is what I was talking about for the vertical asymptotes. Okay, when we find our consecutive vertical asymptotes, we're going to take this k times x minus b, we're going to take that value, and we're going to set it equal to 0 and then pi for the cosecant. Okay, because cosecant is 1 over sine, and sine is going to be a 0 value at 0 and at pi. Okay, so this is where the cosecant function is going to be undefined. And then for secant, we're going to take that stuff and we're going to set it equal to negative pi over 2 and then pi over 2. Okay, remember this negative pi over 2, that's the same thing as 3 pi over 2. Okay. And again, secant is going to be the inverse of cosine, and cosine has a 0 value at negative pi over 2 and pi over 2. Okay, so that would make your fraction 1 over cosine. That would make it undefined at negative pi over 2 and at pi over 2. So that's why we set these equations equal to those values, because it's what makes that fraction undefined. It's the value that has a 0 in the denominator. Okay? So it's a lot of little detail, but it's the same as what we saw before with the tangent and the cotangent. You set them equal to the stuff that makes the denominator 0, or the value, I guess I should say, the radian value that gets you a 0 for the terminal point in the denominator. Okay, so we've got 3 graphs that we're going to do. So example 4 has a couple cosecants, and then example 5 is a secant. Okay. So for example 4 here, in the past, the stuff we've gone through the amplitude, the period, and then the phase shifts. Okay. Now, in the past, what we thought of as an amplitude for this problem would have been this number that's in front of the cosecant. And it's a half. The absolute value of a half is a half. Okay? But we're not really going to think of it so much as an amplitude anymore. That value, for now, is going to be our horizontal asymptote. And it's not just going to be the 1/2, it's also going to be a negative 1/2. So that's going to tell us where the top or the bottom of those little parabola, horseshoe type shapes are going to hit on the graph. Okay? So you can still kind of go through that same order that we've been going through of all these extra little transformations, but now what we thought of for an amplitude in the past is now going to be a horizontal asymptote. Okay? We still have our period that we have to calculate. And cosecant and secant are the inverses of cosine and sine. Cosine and sine have periods of 2 pi, so we're still going to do the 2 pi over k, and my k value is the 2, so 2 pi over 2 is going to be pi. Okay, so this graph's going to have a period of pi, so we'll have every pi will have a little horseshoe, or every pi will have 2 of those little horseshoes, one that opens up and one that opens down. Okay. And then we also have to do our vertical asymptotes. So this is similar to what we've done before with the tangent and the cotangent. Okay, so I'm going to take all this stuff, this 2x, all this stuff after the cosecant, and I'm going to set it equal to the value that would make my denominator 0, the radian measure where I would get 1 over 0 if I did the 1 over sine for the cosecant. Okay, so that's going to be setting it equal to 0. and pi. So then here if I divide by 2, I get 0. And here if I divide by 2, I get pi over 2. So that tells me my first two vertical asymptotes. Okay. So I'm going to mark those on my graph at 0, which again is kind of hard to see, so mark it in the best you can. And then at pi over 2. Okay. Now, those are my first two asymptotes for the first little parabola or the horseshoe. I need one more. Okay. So if I'm going from 0 to pi over 2, okay, those are just my vertical asymptotes. I really have to have a period of pi. And I've started at 0 and I've gone to pi over 2. I haven't gone all the way to pi. So the distance from 0 to pi over 2 is a half. So I have to go another half. So that way I get my complete two-part, two little horseshoe, two parabola graph in there. Okay? So for the secant and the cosecant, you have to think, I have to find my two vertical asymptotes and one more. But I also need pi. Okay? So the distance from your first asymptote to your third one, technically, has to be equal to your period. Okay? So these are the only graphs where you have to do that from, because this is where we have two little parts to our whole period. Okay? So my period now is from 0 to 2 pi, or I'm sorry, 0 to pi, and I have to have two of those parabola or horseshoes in that distance. Okay? So that's why I need 3 asymptotes to get me those two sections where the little horseshoes go. Okay? So now I just have to basically draw them in. Okay? So I'm going to, now my amplitude was a half and a negative half. Okay? So halfway between 0 and pi over 2 is pi over 4. So at pi over 4, I'm going to go up a half. Okay? Because this first little parabola or horseshoe is going to open up, but it's going to come down to that 1/2. Okay, that's my horizontal asymptote. And then for the next little horseshoe, I have to go down to negative 1/2, and I have to do that halfway between pi over 2 and pi. Okay, so it's easy to find halfway between pi over 2 and pi. That's 3 pi over 4. Okay, and then you make your little parabola or your little horseshoe that opens down. And that's it. Now that's one period, okay? If you wanted to extend this and make another period, then you'd have to add in 2 more asymptotes. And then you'd have to have another little horseshoe there. Ooh, that was kind of rough there. It's supposed to be a half there at the bottom. Okay, and then another little horseshoe there. Okay, so now you have 2 periods of this graph. Okay, so this is one period, this is another period. Okay, so each period from 0 to pi, if my period was pi, from 0 to pi, I have 2 of these little parabolas or little horseshoes. Okay? All right, let's try it again. So this one, our amplitude is going to be a half. Again, that's just coincidence. They're not all going to be like that. Okay? But remember that amplitude isn't really an amplitude anymore. That's our horizontal asymptote. Okay? So it's going to be a half, and then it's going to be a negative 1/2. So that's the high point and the low point of where those little parabolas or little horseshoes are going to hit on our graph. Okay? And this one, also, this graph has the k value inside the parentheses still. So if we wanted to rewrite the function, we could. 1/2 cosecant, we could take out that 2, x plus pi over 4. Now this time I have a shift. Okay, I have this x plus pi over 4. So that means my asymptotes aren't going to start at 0 like they're expected to. It's going to shift. And it's going to shift to the left, pi over 4. Okay? Since I'm adding in here, that means I'm going to go to the left on my graph. I do the opposite, remember. Okay? So this will be a good way to double check our graph when we get done. Okay? You don't have to rewrite it this way, but it's a good way to have those values so you can double check your shifting. So I have my horizontal asymptotes. I need my period next. Again, this is cosecant, so that's the inverse of sine. Sine has a period of 2 pi. So it's still going to be 2 pi over my k value, which is 2. So again, my period's going to be pi. Again, that's just coincidence. Part A had the same horizontal asymptote and a period as part B. That's not going to happen every single time. Okay? The difference between part A and B is basically this shift. Okay? So otherwise it was the exact same function, except now I've got this shift that's going on in the parentheses there. Okay, so next I have to find my vertical asymptotes. So I'm going to take all the stuff after the cosecant, so all the stuff in the parentheses, the 2x plus pi over 2, I'm going to set it equal to 0. And then I'm going to set it equal to pi. Okay, because again, those are the values where I get an undefined function because I'd have a 0 in the denominator for 1 over sine. Okay, so sine is 0 at 0 on pi, so that's why we're doing 0 on pi. So then I solve. So I have 2x equals, oops, negative pi over 2. And then when I divide, I get negative pi over 4. Now I said our graph was going to shift to the left pi over 4. Okay, because of this number right here. It's plus pi over 4. That means I'm moving to the left pi over 4. Negative pi over 4 right here. That's where my first asymptote is going to be, except that's not pi over 4. There we go. Here we go. There's pi over 4. Okay. So my graph has shifted. Now over here, I'll have 2x equals, I'm going to subtract the 1/2 pi. So pi minus a half is going to be pi over 2. And then I divide by 2, so I get pi over 4. Okay, so here's my other pi over 4. Now those are my first 2 of the 3 vertical asymptotes that I need. So remember, you have to do and one more. Okay, now my whole distance has to be pi. So I've gone a 1/2 pi from negative pi over 4 to pi over 4. That was a 1/2 a pi. So I need to go another 1/2 of a pi. So I'm going to have my other asymptote at 3 pi over 4. Now it's cosecant, so I'm going to open up for my first little parabola horseshoe thing. I'm only going to go down to a positive 1/2, and then I'll come back up. So I've hit that horizontal asymptote. The second part is going to hit at negative 1/2, and then open down. So there's my other horizontal asymptote there at negative 1/2. Okay. Now again, those points are going to be halfway between my asymptotes. So halfway between negative pi over 4 and pi over 4, that's 0. Hopefully that's easy to figure out. And halfway between pi over 4 and 3 pi over 4, that's pi over 2. Again, hopefully that's easy to figure out. It's very easy to visualize on this graph as well. Okay? So that's my first period. And then if on a quiz or a test, if it said to draw 2 periods, you put in 2 more asymptotes, and then you draw 2 more curves. Make sure they go to the appropriate horizontal asymptote. Okay. Again, there's a lot of detail, a lot of thinking through, but once you actually go to graph, if you've done all this work up front, then graphing it is really pretty easy. Okay, so let's do one more. Oh, there's the book pictures. Okay, notice they've got 3 periods here. 1, and then 2, and then 3 periods for each of the graphs. Okay. Okay, so let's do one more example. Example 5, this is a secant. So this is the inverse of the cosine. Okay. So this one looks a little bit different because my amplitude, which isn't really an amplitude, it's a horizontal asymptote now, is going to be 3 and then negative 3. That's that number out in front. Okay. I'm not going to have a shift here because I don't have anything added or subtracted on with the x, but I still have that k value of a half, so that's going to affect my period. So I'm going to take 2 pi and divide it by a half, so that's going to make my period 4 pi. Wow, that's going to be a big graph. Okay, and actually, I might want to draw this graph by hand. Okay, see if I can keep that keyboard from popping back up. Okay, so I've got my horizontal asymptote and I've got my period. Now I need my vertical asymptote. So I'm going to take all the stuff after the secant, that 1/2 x, and I'm going to set it equal to, now secant gets set equal to different values than the cosecant, okay? Because secant is 1 over cosine, so I need those values where cosine is going to be a 0, because 1 over 0 will make the secant undefined. So I need to set it equal to negative pi over 2, and then pi over 2. And then I'll do one more. I'll still do one more vertical asymptote after I do this. So if I divide by a half or multiply by 2, I'll get x equals negative pi, and then I'll get x equals pi. Okay, so now my total distance has to be 4 pi. So from negative pi to pi, that's a distance of 2 pi. Okay, that's halfway. But then I have to go another 2 pi, so I get a total of 4 pi. So that's going to be 1 pi plus 2 pi, that'll be 3 pi. That'll be my other vertical asymptote. So this graph is going to be kind of big. Okay, it's going to be stretched quite a bit. So let's just start here at negative pi, and then I've got 0, and then I'll have pi, and then I'll have 2 pi, and then 3 pi, and then 4 pi, and then you could do 5 pi if you wanted to extend it. Okay. So at negative pi, that was where I was starting. That was my first asymptote. Okay. And then, okay, so I also have to have my y-axis marked here with the 3 and the negative 3. Okay. Now remember, cosecant and secant, they both start with those little horseshoe parabolas that open up. Okay. So my first one is going to open up here. And at the bottom of it has to be at 3. So then I'm going to have the little parabola coming down like so. And the next one, okay, halfway between pi and 3 pi is going to be 2 pi. So at that 2 pi, I'm going to be down at negative 3. So then that's where the other little horseshoe is going to go. Okay, so there's my graph. If I wanted to keep going, I could. Okay. Halfway between 3 pi and 5 pi would be 4 pi. And then I'd have 5, 6, 7 pi would be my other asymptote. So at 6 pi, negative 3, that would be where my other horseshoe would go. So there's 2 periods. Okay. Now, technically, when I show you this next picture, okay, the book picture, remember that technically the secant curve, when we first drew it, just had this little half of a parabola, and then a whole one opening down, and then the other little half that opened up. Okay, so when I show you this next picture of the book's answer, okay, they have the red as the first period. And then all this purple is just kind of an extension of it. Okay, so this is where we started here. We started at negative pi. Okay, and we just drew in the whole horseshoe instead of drawing in that little half. Okay, and then we had the part that goes down and then the other whole part that goes up. Okay, so just remember that technically the secant starts with the little half that opens up and then the whole one that opens down and then the half that opens up again. Okay, but it's nicer, it looks prettier if you just extend it so that you get that whole parabola or that whole horseshoe in there. And when you put in your asymptotes, you're going to get the regions where the whole parabola would be anyway. So just go ahead and graph the whole thing. Okay. Okay. And then remember that for that even and oddness, okay, technically the ends of a cosecant function go in opposite directions. Cosecant technically goes like this and then like this. Okay, so cosecant is technically an odd function. Okay, and then secant is technically going to be an even function because its ends go the same direction. Because technically it's got this one going up and then down in the middle and then up at the other end. Okay, so again, this is just a refresher of the even and oddness of these functions. Okay, it says here cosecant is an odd function, whereas secant is even. Okay, so that's just a reminder of the end behaviors of graphs that we've talked about in the past. Okay, so that can be a good thing to keep in your mind to make sure that you're graphing them appropriately. But like I said, when you're making these secant functions, you can extend these little pieces so that they make a whole parabola or a whole little horseshoe shape. Okay? All right, so page 405 is where you can practice these concepts. Definitely practice these. These are tricky. We've gone through 6 different types of graphs now. We've got at least 3 separate chunks of information that you need for each type of graph. And when you start doing these all together on quizzes and tests and worksheets, it can get confusing. So definitely practice this. Make sure you get all these little details down for each type of graph so that way when you see them all together, it's not as overwhelming. Okay? Remember, odd answers are in the back of your book, so check them there. Evens are also worked out in the binder in the classroom. And if you have any questions, come on in and see me before school.